Trigonometric word problems. At 50 meters from an oil rig, Romeo looks up at an angle of 40 degrees to see the top of the rig. Romeo is 1.8 meters tall. What is the height of the rig? So if we consider level ground like this, we'll have Romeo standing here, and we know that Romeo is 1.8 meters tall, and he looks up at an angle of 40 degrees. So if I put another line here parallel with Romeo's head, and then he looks up at the top there like so, and he's looked up at 40 degrees, and we want the height here, and we're told that this is 50 meters. He's 50 meters from the rig. So if we want the height of the rig, what we're going to do is work out the length here in the triangle. So if I call that, say, x, and then we'll add on Romeo's height, and we'll get the answer. So compared to the 40 degrees, we can see that this side here is the opposite, and this one is the adjacent. Start with mnemonic, so, car, toa. Opposite and adjacent, we're using the tangent. The tangent of the angle we know is equal to the opposite, which is x, divided by the adjacent, which is 50. Rearranging, x is going to be 50 multiplied by tan 40. And then we'll calculate x. So that is going to be 50 multiplied by tan of 40, 41.954, and so on. And then the height is going to be that 41.954 and so on, add Romeo's height. So if we just add 1.8, and that's going to be 43.75. Correct to 2 decimal places. The center of the clock face in a tower is 20 meters above the ground. So that's 20 meters from there to the center. The hour hand is 1 meter long. How far above the ground is the end of the hour hand at 7 AM? Well, the hour hand would be pointing down here at the 7. So it's going to be below the center. Let's try and get a diagram of that. So the center is here. So it's going to look something like this. It's going to be pointing here, and this is 1 meter. So if we consider that the whole angle here between 6 and 9 is 90 degrees and cut in 3 parts, this angle just here is 30 degrees. And this, subtracted from that 20, would be the height of the tip of the hour hand above the ground. So it's hanging this far below vertically. Let's just draw that triangle out a bit better than that. So it looks something like that. So this is the straight down towards the 6, and that's the distance that we actually want. Let's call it x. we know this is 1 meter, and we worked out that this angle here would be 30 degrees. So compared to the 30, this is the adjacent, and the 1 is the hypotenuse. So car TOA, adjacent hypotenuse, we're using the cosine. So the cosine of the angle, and we know the angle, is equal to the adjacent over the hypotenuse. So that just gives me that x is equal to cos 30. So x is going to be just cos 30. So cos 30, which is 0.866, and so on. And therefore the height of the hand would be the 20 to the clock face, take away the 0.866, and so on, that this hangs below. So it's going to be 20, 20, again, didn't register the 2, 20, take away my last answer, and that's going to be 19.13, I'm going to call that. So 19.13 meters, correct to 2 decimal places. Now we want to do the same sort of thing, but at 10:30. So let's draw the clock face again, and of course we know this is the center, and we know that this is 20 meters above the ground. And on the clock, this is the 9, the 12 is up here, so we'll have 10 and 11, and at 10:30 the hour hand, let's just draw that a little bit better, the hour hand will be exactly halfway in between 10 and 11. We know it's 1 meter long, so it's going to be above, just here. So the length we want will be this one. I'll draw the triangle better in a minute. Now if we think about it, it's exactly halfway going from 9 to 12, and 9 till 12 would be 90 degrees, so the angle here must be 45 degrees. Let's do a slightly better drawing of the triangle. So this is the hand itself, 1 meter. We know the angle here is 45 degrees, and we want this value here, which I'll call y, and we'll add that onto the 20 to get the height of the end of the hand. Now if we look at that, compared to the 45, this is the opposite, this is the hypotenuse. So go to the mnemonic, so car TOA, opposite and hypotenuse, we're using the sine. The sine of the angle is going to be equal to the opposite over the hypotenuse. If that's just divided by 1, y is just equal to sine of 45 degrees. And so we can calculate that. So we want the sine of 45, 0.707, and so on. And then the height is just going to be the 20, add the 0.707, and so on. And so that is going to be 20.71 meters, correct to 2 decimal places.